Welcome to another unit in this preparatory course Mathematics. This time I'm going to talk about the so-called factorials and the binomial coefficient. Actually, the factorials, that's, well, mathematical way of calculating something, but this can also be used, similar to the binomial coefficient, in something called combinatorics. So basically, if you have certain number of objects and you want to know how many ways there are to arrange those number of objects, that's where you can use the factorial. So if you're considering permutations, that's actually where factorials come into play. Okay, but what is a factorial? Well, a factorial can be calculated for any natural number and for zero. And that's basically multiplying all those numbers, if this is a natural number, all those numbers up to this specific number. So if we have a number n, so multiply all the numbers from 1 till n. So for example, if you have like 3 factorial, that's like 1 times 2 times 3. If you have 5 factorial, that's 1 times 2 times 3 times 4 times 5. So that's relatively straightforward. However, we can also see, as I said, that's the different possibilities to arrange n objects. So if we have 4 objects, we have n factorial, that's like the n with the exclamation mark, n factorial possibilities, or 4 factorial possibilities, to arrange them. So it's like 1 times 2, it's 2, times 3 is 6, times 4 is 24 possibilities to arrange them. That's not this much. But if we just expand this by one more, so if we take 5 objects, it's again 24 times 5, so it's already 120. If we have 6 objects, it's 720. So this grows very, very fast. Okay, so with this in mind, we have an application for this, and we know how to calculate this. We can also write this in a slightly more mathematical way. That's if we use the product sign. We will have a different unit here in this course where I will also explain what the product sign means. Basically here in this context means insert this number down here into this function, then insert the next number, the next integer here, next integer until you're at the integer up here. And whenever you have inserted this, take the result and multiply it with all the things before. So here I start with 1, then times, then I insert 2. Times 2, times 3, times 4, times 5, times 6, until I'm at times n. Then I'm here at the top, and I finished. Okay, so that's like a short look ahead on product signs. There's, however, one thing I need to mention before we can continue. I said we can calculate factorials for all natural numbers and for 0. But for 0, we're not multiplying all of this with 0. We just consider, well, how many possibilities are there to arrange 0 objects? Well, there's only one possibility we have where we have nothing, and that's actually the one way to arrange nothing. So here we can keep in mind 0 factorial is always 1. Well, let's have a look at an additional example. Here we already have like 5 factorial, so 120 possibilities to arrange something. Well, once we know the factorials, we can use them in a different context, and that's the binomial coefficient. The advantage is the binomial coefficient can also be used in a practical context. But before we get to this, first off, how do I calculate this? Or rather, also, how do I write this? This is something which looks like a vector. So that's the left part here. The 2 brackets and in between an n and a k. This, however, is not referred to as a vector. That's the binomial coefficient. So here we always say n over k, with the additional comment that n always needs to be either the same as k or larger. Or in other words, k can at most be the same as n, but always needs to be smaller. But k also needs to be at least 0. So the smallest possibility here would be n over 0. Or, as n could be the same as k, 0 over 0. On the other part, we could have n over n. But other things are not possible. So we cannot have n over n plus 1. So something like 7 over 8 is not possible. And something like 2 over minus 1 is also not possible. And well, how do we calculate this? Well, first off, we calculate the factorial of n, divide this by the factorial of k, and also by n minus k factorial. Okay, so might look strange, but we can interpret this also in a practical context, as I said. In the practical context here is, I again have n objects, and I want to draw like a sample from the n objects, a sample with k objects. And then n over k tells me how many different samples exist. So I have k elements, k people, and I want to build groups of size k. How many different groups of size k are possible in this case? This becomes a bit clearer when we take a look at some examples. Let's start with this one here. If you know, like the lottery, in Germany it's like 6 out of 49. Then you can consider, well, how many possibilities, how many possible outcomes are there for the 6 out of 49? Then we get, as a result, it's roughly 14 million possible outcomes. And you have to pick the one which is actually the winning one. Okay, so that's the idea behind the binomial coefficient, if we apply this to Lotto. If you go with, again, the way of people and subgroups, so if you have like a team of 5 people, you have to build a group, a task force of 3 people, you would have like 5 over 3. So this would be n as 5, so we have 5 factorial, 120, divided by k factorial, so 3 factorial, which is 6. So 120 divided by 6, divided by n minus k, so 5 minus 3, that's 2 factorial, which is 2 as well. So we have 120 divided by 6, divided by 2, or 120 divided by, here, 12. So as a result we get 10. The advantage is, this is a neat way of writing this. However, we will see this binomial coefficient in 2 applications again. First off, when we talk about the so-called Pascal triangle, because here in the Pascal triangle, at least in the way I present this here, the n, that will be our rows, and the k, that will be our columns. So if you know how the Pascal triangle works, you know what the result for the binomial coefficient will be. On the other hand, the binomial coefficient is the mathematics happening behind the Pascal triangle. And well, you might have wondered, it's called binomial coefficient. Maybe you heard something about the binomial forms. We also have the unit on this here. Well, this also refers to the binomial forms. If we have something binomial form, as you notice, to the power of 2, then n would be 2. If n is 2, then k actually has 3 possibilities. K could be 0, 1, or 2. N over 0, that's the value before the first expression. So 2 over 0 is the first one. 2 over 1, that's the value before the second term. And 2 over 2, that's the value before the third term. So 2 over 0, that's the 1 before the a squared. 2 over 1, that's the 2 before the a times b. And 2 over 2, that's the 1 before the b squared. Well, now you might imagine n not necessarily has to be 2. N could be any natural number. So if you want to find the values for, let's say, a plus b in parentheses to the power of 5, you simply calculate all binomial coefficients with an n of 5. Then you get all the different coefficients. So it's a very easy, very neat way to calculate relatively fast, very large binomial forms. And well, that's then also already everything I wanted to mention here. So I can only say goodbye and see you next time.